Hello and welcome back to the channel. It's Mark from PowerSonic and Apprentice 1-to-1. Today we're going to have a look at ModXoft ElectricalOM again, and this time looking at a three-phase solar PV system. We're going to build it up. There's a few other circuits on this as well. We'll pop them all in there and I'll show you how ModXoft ElectricalOM helps verify the design process for both regular electrical work and also the solar side. It's had a recent update. The team at ModXoft are always making changes to this, listen to their users and tweaking the product based upon that feedback. They're really receptive. So if you're a user of ModXoft ElectricalOM and there's something you want to see that's not there, do reach out to the team because they are all ears to those things. But without further ado, I'm going to spin you around to zoom into this screen and we'll have a look at the creation of this little system we're popping together here. And I'll try and voice it over in one hit all the way through. We'll see how we get on with that. Let's get straight to it. So first up, we need to create our source. So we do that by inserting a source, and we've got our three-phase and neutral. If we click into there, you can see it's predefined with certain values. So we can adjust our ZE. So if we know what the value of ZE is, for example, on this install, we can say it's 0.14. And again, the same for our short circuit loop. If we know what that value is, you can change it. So if you know it's 6 kA, for example, pop that in there and the values shuffle about. Your earthing, so we're going to use the earthing conductor. It's just going to be a single core 16 mil, about a meter long. We can pop that in there. There will also be an earth electrode. So if we say the value of an earth electrode is going to be 40 ohms, you can calculate, and that will tell you the rod size you need, basically based on the ground conditions. So if you've got dry sandy gravel, you'd expect an earth electrode resistance of 800 ohms based on this particular type of rod. So if we say we've got a 4 meter rod and we're in, we'll say sandy clay, we'd expect 50 ohms, which is a good value. So we can use that to help us calculate what to expect in terms of our electrode as well, which is super duper useful. We're going to use the tails on this as well. So we're going to again use the single core thermoplastic. We'll set them to 25 mil in size, about a meter long. We'll use the overcurrent protective device. It is just going to be BS1361 fuses, rated at 100 amps. We'll have the icons on there as well, because why not? The premises, we'll go for small shop or an office. And we are going to be prosuming on this one, so we'll pop that in there as well. Any other options, that's kind of us with our source as a start point. So you can see it's populated that data into the schematic already now. So we've got our tails, our fuse is now a meter. So first up, we need the distribution board. So again, we right click, insert, and choose a distribution board, three-phase. So that's popped straight in there. It's using a four-way board, which is handy because that is what we are utilizing. So with this, if we right click and say what we're going to insert in this case, so we could have a connection, for example, a converter, a three-phase solar PV inverter, which we're going to put into way one. Now you can see it pre-populates that with lots of different bits and pieces, and we've also got some pre-populated stuff leading down to our distribution board. So first up is to change all that. So with the supply circuit from the meter, if we go back into that, we're not going to use any overcurrent protection because that's just off the service fuse. The earthing is going to be a separate conductor, and again we'll have that as 16 millimeters. So we can pop that in there as well. The phase and neutral conductors, again, they're just going to be the tails. So we want those at 25 mil, and they're going to be on our space from a surface clipped direct. So let's pop that on there. I think we've still got the isolator that's going to be listed in there. Let's see if we can find that. So yeah, it's using an isolator. We'll pop that as 100 amp just to say that it's in there, because why not? Apply those changes and go back to look at the schematic. So if we see there now, we've got our tails into the meter, then the tails from the meter with the earth leaving off through the 100 amp isolator to the distribution board. Now again, with this final circuit for the solar PV, you can see we've got a few things already pre-selected there, but we'll start by giving it a description. So we'll call this give energy, for example, 11 kilowatt, and we'll just call it three phase. So now we can set our rating on that. You see we've got the AC kilowatt value. So if we put that to 11 kilowatts, and we can also size the PV array on there as well, but we'll get to that when we pop the string details in. For the minute, we're going to concentrate on this. So for our phase neutral conductors, we're going to go for an XLPE cable, but we'll run it at 70. Again, we'll say that it's going to be on perforated cable tray. We need to set our length, which is going to be about 15. So that can pop on there, and our cable size will go for 10 mil. So now we need to go to our protective devices, and we're going to use those in this case, and we'll change that using Proteus breakers, and we're going to be using RCBOs. C-type, and these are the 3 module 4 poles, and we'll set that to 32 amps, and it's a class A, type A overcurrent protective device. I've just realised I put that to 11,000 rather than 11 kilowatt. That'll help things out a little bit better. So we've got our circuit protection. Now you can see here that the MCB aspect of this that it wants to use rated at 6 amps. That's on the circuit. I'll go back to the schematic first to show you, so we'll save that. If we go back to the schematic, you can see it's got a protective device in there that we're not using. We've got our RCBO down here, so if we click into this aspect here, we can turn that off, so we don't want that 6 amp protector there. So we've got the phase neutral and earth. We've got our 10 mil sizing. You can see we've got a warning on that. It's actually saying we might want to consider bigger, so we'll look at that in a minute. If we have a look further down now, we can look at the earthing. So we're going for the cable, armour, and a separate conductor. Sorry, the core of the cable. So pop that on there, and we've now just got the warning here again around the size of the cable that we're using on our perforated tray for the 11 kilowatt PV inverter. Now we can adjust the settings on this as well. So you can see we've got a max voltage of 1000 volts and a minimum voltage of 120. And again, that would depend on the inverter that you're using, so you can get all of that information from the product data sheet. So if we save that and go back in, you can now see we've got our 3-phase final circuit running down, which is 5-core 10 mil steel wire armour, and we've got that RCBO, which is sat there looking after our circuit. It is also showing an isolator, so we can go in and get rid of that because we're not using an isolator. In fact, we're not going to use that. We'll go back to circuit protection and pop that in there. So I put that in the wrong place. We'll go for Proteus again, RCBOs, 4-pole type C, and we want the 32 amp on there, which is satisfying that product protection now, because I had popped that in the incomer disconnection isolation, which is where it didn't need to be. So we could actually downsize our cable, but I'm going to leave it at 10 mil just for future proofing and to help us a little bit with the old volt drop. If we apply those changes now, you can see all of the reds have gone, so we've got no warnings, and we can go back to our schematic. So that is now setting us out ready to go with that particular circuit. So that's our 3-phase PV all in place. So we're now going to insert another circuit. So if we go to insert, and we're going to have a final 3-phase circuit, and in this case we're going to use an EV charger. So we're going to have a 3-phase EV charger. So again, drop your little list down, we can see electric vehicle charging equipment. Watts, I'm going to put that as 22. This is where it gets a bit confusing because the last one was looking for it in kilowatts, and this is watts. So it's just watching out for that as you're developing your circuit layouts. The phase neutral, so we're going to go for an XLPE again, and this one is going to be on perforated cable tray, and it's going to be approximately, we'll go for 25 meters on this one, and we'll size it at 6 mil. Our protective device, we're going to use that, but we need to change what it is. Again, it's Proteus, and again, we're going to go for RCBOs and the 4-pole. We'll go for a C-type, and we'll pop it on a 40 amp breaker. Type A again, so we've got that popped in there as well. The earthing, we'll do that as a core of the cable too. So pop that in there, and we can apply those changes, go back to the schematic, and you can see now we've got our EV charger circuit as well. Now we also got a few little local circuits just for sockets and lighting. So we're going to insert another circuit. This one is just going to be a single phase circuit. So again, you can see it's pre-populated some data, so you need to watch out for that with your circuit layout. If we go back into this one, this is just going to be the sockets. So if we pop that in there, we should have an option to choose some sockets from this list, if I can find them. So we've got a socket radial circuit, and we'll just call that warehouse sockets. Really simple installation here. We'll say on this one we're going to 200 watts is probably okay for a domestic environment, but they're going to use a little bit more here. We'll pop it at 500 watts for each socket outlet, and they've got 6 sockets for want of a better example. And if we go back to our phase neutral conductor, again, in this case, we're going to be using LSF. So this is flat twin 90 degree. So we'll pop that on there and we can run that to 70 degrees again. This is going to be in conduit on a wall. So we'll pop that in there as well. Now, usually you'd use singles, but this is just really for neatness than anything, and also to use the LSF. And we'll do that in 4mm. Go to our protective devices now, and we can change the protective device. And again, we're on with our Proteus. Again, we're going for our CBOs, and we've got our 10 kA we need here. We're going to go for a type C, and we'll set that to 32 amps. So that's in there. Our protective device is now sorted, so we're going to say that AFDD is not required to clear that warning, but it is asking us to make that decision. You can see now with our sizing, because we've gone for that 32 amp breaker as a protective device, it's saying we need to upgrade our cable size. So you've got options now. We're either going to downrate the circuit, or we need to upsize our cable, and that is because of the conduit. So if we was putting this on tray, for example, if we just do that or click direct, you see the current carrying capacity of the 4mm adjusts and suddenly becomes okay. But we'll stick with the in conduit on a wall, and is what we're going to do is just drop the value of our protective device down to a 20 amp breaker, because we don't need that 32 amp rating for the UC. There's nothing of real high power consumption. It is more just spreading out somewhere they can plug a bit of equipment in. So we've got that on there as well now. I have noticed a little warning there that we've had pop up on this one, so we'll see what that warning is related to. I suspect it'll be an isolation point somewhere. Let's go back and look in the schematic. So we've got our RCBO, which is in there. It's 40 amp 10 kA rating. We've got our 5 core. What's this little thing here? Let's have a look. DB1 FC1 critical 3-pole defective device, EV charging point protection against electron, must disconnect all live conductors. Okay, so that's looking at our overcurrent protective device from Proteus here, so we need to change that to 4 poles, and that should clear that fault away. Because as we know, the 3 module 4-pole RCBO from Proteus does open the neutral as well. So important to spot those things as you're moving along, but that's our socket circuit in now, so we've got the 6 of those. We need some lighting, so we're going to insert another final circuit, again just single phase, pop that up, and again go across and see if we can find the lighting circuits. So pop lighting, and we'll go for the 6 light fittings again, and these are 48 watt fittings, so we can pop those on there. And again, we'll just put that down as LED high bay. In fact, we'll change it to a bit of a better example and pop them at 150s. Why not? So the phase neutral conductor on these ones, we're going to go for, again, we'll go for just the twin and earth 90 degree XLPE. And again, we'll do it in conduit, because why not? It affects the values a bit better in conduit on a wall. The length on these is going to be, we'll say 50 meters. We'll push it a little bit on this one. And we're going to use 2.5mm just to make it fun to terminate them. So we've got that on there, the protective device. We're going to use that, but we need to change it. So again, we're going to have Proteus. Again, we'll have an RCBO. We'll go for a C-type. And this time, we'll select a 10 amp just to give us a bit more. Well, let's keep it at 6. Why not? We'll keep it at 6. So we don't need out fault protection on that. It's not asked us for the warning because it's not a socket as such. But we've got that there, and there's no warning shown. So if we apply those changes, go back to the schematic, and we can have a little look at here again. So we've got our RCBO in circuit, we've got our final circuit, and we've got our lights. So if I zoom out a little on that, you can kind of see the layout a bit better. But we've got our supply right at the top, running through that fuse into the meter. We've then got an isolator pre the distribution board. We've then got our PV. We've got our EV, and we've got these 2 final circuits for lighting and power. We are missing our strings. So if we go to insert on the end of there, and a solar PV string can pop up. So we can go into this option, and this is where we can define what we're doing with the array. So we'll call these Jinko panels, why not? And our string, we're going to have, we'll say 12 panels in it, and we'll just assume that these predefined values are what they are. So we've got 550 watt panels within, and we're going to use a 6mm cable. Just select that off there. And the approximate length, again, we'll set to 20 meters. And it's solar energy cable, and it's just clip direct, flat touching, or actually on an unperforated cable tray. No, let's use something we haven't used. What should we put them in? We'll put them in an underground duct, and we'll say we've complied with these regulations, just for something different as an installation method. So we can see that on there. And you see in the volt drop, we've got 13.49% on L1, and that's because we've got the one string on there. So it's really not reflected in the overall installation. We need to make sure we're getting the full spread across the entire system. So we'll keep going for the minute, and we'll look back at that in just a second. So you can see we've got our 6mm there. That's our first string done. So if we go back to the schematic and apply those changes, and we can have a little look on this and see where we're at. So we've got one on there now. We're going to add another string in, a solar PV string, and again we'll keep it the same. So we'll pop that onto here. We'll call them again Jinko panels. So they're popped in there, and then we'll have another 12. Again, we'll just stick with the defaults. We'll pop those in there, and again, we'll say these ones, they're going off in a different direction. They can be flat touching. These ones are only going to be 15 meters, and again, we're using that 6mm size. So that's another option onto the system. And again, with the voltage drop, you'll see it's still sitting it all on L1. So we need to keep that in mind. We'll have to make some changes to that in just a second. If we go back to the actual string the inverter itself, save those changes, you'll see now it's starting to pop a few little things in here. So we've got our peak power, peak PV power. We'll set that to, let's set it to 13,200 just to match what's actually going on with our inverter. So we've cleared that particular fault away now, and we've got the volt drop within L1, L2 and L3 shown as 0.2. If we have a look in the actual list here, you can see what we've got in terms of our volt drop as well. So this is on the actual inverter, and it's giving us a maximum cable length, and that's trying to stay within 2%. I think I've got that set to on this particular thing. So if we save that now, and we can see our problems have all cleared away. So the volt drop's all much happier. It's dropped away because we've changed the inverter sizing basically, which is what we did in this settings box here. As soon as you've got that set up to match with what's connected to the system, you start to get that generating across all three phases. So we can see that now taking place, which is smashing. We can add another string if we want. So we have a super duper inverter, and we're going to pop another PV string on. Again, we can click into here, and again, we can call it Jinko panels just because they're all Jinko panels. Why not? And again, we'll set it to 12, 3 equally sized strings. If we go back to our phase neutral and earth conductors, we set those to 6mm. And again, we'll say they're clip direct on the system. You can see the voltage drops come up as a problem again, and that's because we have popped another size inverter on. So you can see we've got that red warning on here. So we're going to say our PV peak, we'll just set it to 25 kilowatt. So we're way above now. So it will happily run that across all three phases. So we can see our DC-AC ratio is 1.8. If we click that box here, it tells you what industry standard is. So our oversizing is probably a little bit high in this circumstance, but it is what it is just from using the preset values. Again, you can adjust your volt drop limit. If you want to come down to 2% or even 1%, you can do that. And then any warnings would apply to the circuit based upon that design. It depends how strict you want to be with that. So if we go back to the schematic now, you can see we've got our 3 strings on the inverter. It's 11 kilowatt. We've got our final circuits for the socket. If we want, we can show the calculations within the circuits. So if we click that on here, show circuit calcs, it'll tell us what all of those things are. If we zoom in at the end, what the expected ZS's are, and your fault currents that you may find within those circuits. So that's super useful. And the same on the solar side as well, it'll pop all that information in at an inverter level. So if you want to know what your anticipated calculations are, they can all be shown within this picture form. Now, if we go into UK Forms and we can create a new certificate, and we just click OK, it's going to be an electrical installation certificate. If we then open that up, and we're just going to jump through to the distribution boards, you'll see it's created them for us. So this is our main board. We've got DB1 here with our final circuits, which is the solar PV. That's called FC1 because I didn't rename it, but it's the EV charge point. And we've got the sockets and the high beta lighting. All of our cable types and our sizes and our protected devices are all entered. And we just need to start entering the values in for our test results, which is super duper handy. And again, if you were using the app, so mobile OEM, you can import those test results from the app straight into here. So it'll all kind of sync together, which is really handy. The other useful feature to all of this is if you are to go into reports, and I've shown this loads before, this is like a superpower of data. But if we check the box for all data and generate the report, it'll run a full project analysis and produce you a report based upon that. And the data in this is scary when you dig into it for all of your volt drop calculations. It even does arc flash as well to tell you if that's going to be a factor. And it will do your schematics and such. You know, there's pages and pages of this stuff. I'll just flick through it super duper fast. But, you know, if you're putting this forward as part of a proposal, having this data for the consumer or client to see, to know you've taken account of all of this, it's essential on bigger commercial stuff, really. But, you know, it's useful at every level. And then the end of all of this, for when you're submitting your handover packs and stuff, you've got your circuit charts, which show all of the values. You've got line graphs that you can use on the equipment as well, and you can print these off and stick them with the boards and such too, along with a full set of test results. So I think that is really, really useful. And if you're working on this and want to export it as a PDF to send to a customer, you can do that. If you want to save this and share it with a colleague, again, you can do all of those things. So I hope that has been useful, having a look through ModexSoft ElectricalOM and just building up this little system here for a solar PV at 3-phase, an EV charge point, a socket and lighting circuit. Obviously this is scalable, and I've shown before where you can do the CAD plan. So if you want, you can import a CAD drawing and you can start dragging and dropping your sockets, your lights around that plan, and it will automatically populate that into the schematic. You can even set the heights of the accessories and stuff. I'll link in the description over to the ModexSoft YouTube channel because they've got stuff on there covering this already. And if you just search on my channel, I have covered that before at a single phase level where we had a CAD plan and we started dropping sockets in here and there. It's an absolute powerhouse to help us as electricians. And if you're not using this already, you really should think about it. There's a free 14-day trial. I'll drop a link to that in the description as well. Just for total clarity, ModexSoft ElectricalOM help us out through Apprentice 1-to-1. So this, I guess you could class as paid or sponsored, so I'll click that little button. But we've been using this for years, and I wouldn't do a solar proposal or any kind of electrical certification and design without using this now. It is incredible. So worth checking out. It's free for 14 days. What's the worst that could happen? And the tutorials that are out there are off the scale as well. There's webinars that you can sit through and watch, people who know how to use this way better than I can. Just wanted to give a broad overview. If you've got any questions or comments, do drop them in below. If you've liked the video, give it a thumbs up. And if you've not already, please do subscribe to the channel because it helps spread these out further and further. And I'm making a bit of an effort to grow this channel now. Hopefully we can push forward. Now we're above the 10K mark and see where we can get to. Thank you all very much for those of you who subscribed already. And otherwise, I'll see you on the next one.